Hello, welcome to the Mark Janard Show, the cybersecurity show. They saying analog computing is the future of AI. You know, I guess, they're tired of GPT, all these. Now they're saying analog computing. So I'm going to break it down in this video. So without further ado, let's get right into it. We're going dark. So let's start with the definition of analog computing. Now, analog computer, any of a class of devices in which continuously variable physical quantities such as electrical potential, fluid pressure, or mechanical motion are represented in a way analogous. Peter, you can put that on screen. Analogous to the corresponding quantities in the problem to be solved. The analog system is set up according to initial conditions and then allowed to change freely. Answers to the problem are obtained by measuring the variables in the analog model. Who is the inventor of analog computing? One person is often considered to be the father, right? The father of analog computing, and that is Vannevar Bush. And sorry if I mispronounced your name, sir. He was an American engineer, right? And an inventor who developed the differential analyzer, one of the first analog computers in the 1930s. Please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. So some examples of analog computing: amplifiers, operational amplifiers, mechanical integrators, slide rules, tide predictors, electric integrators, etc. So these are in use to solve the problems related to partial differential equations, electronic machines, and also neural networks. Here is the reason why they're saying that, analog computing is the future. And that is because of smart sensors, right? So smart sensors is what's being said is smart sensors are constantly draining energy from our devices. So thanks to falling manufacturing costs, the number of sensors in the world is expected to dramatically increase in the future. The nonprofit Semiconductor Research Corporation predicts that 45 trillion sensors will be generating 1 million zettabytes of data per year by 2032. What? Those sensors will also be constantly draining energy. Like, what kind of energy? Mark, this doesn't apply to me. What are you talking about, Mark? Oh, your smartphone. That's what I'm talking about. Your smartphone. Yeah, you always got a smartphone that's draining battery. Yeah. Now I got your attention now, huh? So your smartphone, for example, has sensors that are always on, digitizing everything they hear you say, so they know when you're trying to get the attention of an AI assistant. So yeah, is spying, huh? So being tied to a battery that needs constant recharging limits what we can do with our sensors. And if the batteries powering them are being charged by fossil fuel generated electricity, which they likely are, the sensors are also contributing to the problem of climate change. Now we're going to bring in analog computing. So analog computers could be part of the solution to sensor power problem, right? To the sensor power problem. These are the types of computers we relied on before digital computers, and they don't need to translate their inputs into any special computer language before they can process it and deliver a meaningful output. So let's look at the example of Mercury, right? There's a Mercury thermometer is a simple example of an analog computer. Expose the end of it to whatever you're trying to take the temperature of, and the heat will cause the mercury in the thermometer to expand or contract. It'll then climb the device until it's level with the number indicating the temperature. Another analog computers are far more complicated, with complex systems of valves, gears, vacuum tubes, electric circuits, and more. And various designs could be used to calculate everything from tide levels, right, like we previously discussed, to the answers to differential equations. I couldn't stand differential equations. I couldn't stand it. That's what I have for you today. Please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. Also, please hit the notification bell and the like button, but hit the notification bell so you know when I am releasing new videos. Also, comment, is there information I missed, should put on? Please let me know in the comment section below. Stay safe, see you in the next video.